Generally, electrical rooms with dimensions of 20 feet by 20 feet or larger require 2 exits or entrances. This requirement is based on the need for safe and efficient egress in the event of an emergency. The code reference that addresses this requirement is NFPA 70 National Electrical Code, Article 110.26, Exit Facilities for Electrical Closets and Rooms. The specific wording states where the total floor area of electrical closets or rooms exceeds 80 square feet or 7.43 square meters, at least 2 exit facilities shall be provided. In the case of a 20 feet by 20 feet precast concrete pump house, the floor area is 400 square feet, which exceeds the 80 square feet threshold specified in NFPA 70. Therefore, this pump house requires 2 exits or entrances. Additional considerations to keep in mind: firstly, the exit should be located on opposite sides of the room to ensure a clear path of escape in any direction. Secondly, the exit should be marked with visible signage and emergency lighting. Thirdly, doors should be self-closing and equipped with panic hardware for quick egress. Fourthly, the room should have adequate ventilation and overhead lighting. In conclusion, based on the applicable code reference NFPA 70 Article 110.26, the 20 feet by 20 feet pump house requires 2 exits or entrances for safe and efficient egress in an emergency. Let's delve into the specifics of NFPA 70 Article 110.26 and how it dictates the necessity for 2 exits in electrical rooms exceeding 80 square feet. This regulation isn't arbitrary. It's rooted in ensuring personnel safety during unforeseen events such as electrical fires, equipment malfunctions, or other emergencies that could occur within these confined spaces. The primary concern is to provide occupants with multiple escape routes, minimizing the risk of entrapment and facilitating a swift evacuation. Consider the layout of a typical electrical room. It's often densely packed with electrical panels, transformers, switchgear, and various control systems. These components, while essential for power distribution and control, also present potential hazards. A single blocked exit could prove catastrophic, especially in a smoke-filled environment or during a power outage where visibility is compromised. By mandating 2 exits, the code significantly reduces the chances of a single obstruction hindering evacuation efforts. The placement of these exits is equally crucial. They shouldn't be situated close to each other, rather, they should be strategically positioned on opposite sides of the room. This ensures that regardless of where an emergency originates, there's always a viable escape path available. Imagine a scenario where a fire erupts near one exit. With 2 exits on opposite sides, personnel can quickly move away from the hazard and evacuate through the alternative route. Moreover, the requirement for 2 exits promotes better internal traffic flow within the electrical room. Technicians and maintenance staff can move more freely and efficiently, reducing the likelihood of accidents or collisions. The code also emphasizes the importance of clear and conspicuous signage for both exits. These signs must be readily visible, even in low light conditions or during a power outage. Emergency lighting plays a vital role in illuminating the exit paths and guiding occupants to safety. Furthermore, the doors leading to these exits should be self-closing and equipped with panic hardware. Self-closing doors help to contain smoke and fire, preventing them from spreading to other areas of the building. Panic hardware, such as crash bars, allows for quick and effortless egress, even when hands are full or visibility is limited. Beyond the 2 exit rule, other safety considerations are paramount in electrical rooms. Adequate ventilation is essential to prevent the buildup of heat and hazardous gases. Overheating can lead to equipment malfunctions and potential fires, while the accumulation of gases can pose explosion risks. Sufficient overhead lighting is also crucial for ensuring a safe working environment. Proper illumination allows technicians to perform their tasks accurately and efficiently, reducing the chances of errors or accidents. Regular inspections and maintenance are also key to maintaining a safe electrical room. Faulty equipment should be promptly repaired or replaced, and any potential hazards should be addressed immediately. In this specific case of the 20 feet by 20 feet pump house, the application of NFPA 70 Article 110.26 is clear. With a floor area of 400 square feet, which significantly exceeds the 80 square feet threshold, 2 exits are mandatory. This requirement is not merely a suggestion, it's a legally binding code that must be adhered to in order to ensure the safety of personnel and compliance with local regulations. Failure to comply with this code can result in hefty fines, project delays, and, more importantly, an increased risk of accidents and injuries. Therefore, it's crucial to prioritize safety and adhere to all applicable codes and standards when designing and constructing electrical rooms. Let's expand on the importance of proper ventilation and lighting within electrical rooms, as they are critical components of a safe and functional workspace. Ventilation plays a dual role. Firstly, it helps to dissipate heat generated by electrical equipment, and secondly, it prevents the accumulation of hazardous gases. Electrical components such as transformers, switchgear, and power supplies produce significant amounts of heat during operation. If this heat is not adequately dissipated, it can lead to overheating, which can reduce the lifespan of the equipment and increase the risk of failure. Overheating can also cause insulation to break down, creating a fire hazard. Proper ventilation systems, including fans, louvers, and air conditioning, help to maintain a stable and safe operating temperature within the electrical room. These systems ensure that heat is effectively removed and that fresh air is constantly circulated. In addition to heat, electrical equipment can also emit hazardous gases such as ozone and sulfur hexafluoride. These gases can be harmful to human health and can also pose an explosion risk if they accumulate in sufficient concentrations. Ventilation systems help to remove these gases and maintain a safe and breathable atmosphere within the electrical room. The design of the ventilation system should take into account the size of the room, the amount of heat generated by the equipment, and the type and concentration of hazardous gases that may be present. The system should also be regularly inspected and maintained to ensure that it is functioning properly. Moving on to lighting, adequate illumination is essential for performing tasks safely and efficiently within an electrical room. Technicians need to be able to clearly see the equipment they are working on, and they need to be able to identify potential hazards. Poor lighting can lead to errors, accidents, and injuries. The lighting system should provide sufficient levels of illumination and should be evenly distributed throughout the room. The type of lighting used should also be appropriate for the task being performed. For example, tasks that require fine detail may require brighter and more focused lighting. The lighting system should also be designed to minimize glare and shadows, which can make it difficult to see clearly. Emergency lighting is also a critical component of the lighting system. In the event of a power outage, emergency lighting provides a backup source of illumination, allowing technicians to safely evacuate the room. Emergency lighting should be powered by a separate source of energy, such as a battery or generator, and should be automatically activated when the main power supply fails. In addition to ventilation and lighting, other safety considerations are also important in electrical rooms. These include fire suppression systems, grounding systems, and personal protective equipment. Fire suppression systems, such as fire extinguishers and sprinkler systems, can help to quickly extinguish a fire in the event that one occurs. Grounding systems help to protect personnel from electric shock by providing a path for fault current to flow back to the source. Personal protective equipment, such as gloves, safety glasses, and hearing protection, can help to protect personnel from injuries while working in an electrical room. By taking these safety precautions, it is possible to create a safe and functional workspace for electrical technicians and maintenance staff. Let's further discuss the importance of grounding systems in electrical rooms. Grounding is a critical safety measure that provides a low impedance path for fault currents to return to the source, thereby minimizing the risk of electric shock to personnel and preventing damage to equipment. A properly designed and installed grounding system ensures that metallic enclosures, equipment frames, and other conductive parts are at or near ground potential. This prevents dangerous voltage differences from developing, which could lead to electric shock if someone comes into contact with both a grounded surface and a live conductor. The grounding system typically consists of a network of conductors that are connected to a grounding electrode, such as a ground rod or a metallic water pipe. The grounding electrode provides a connection to the earth, which serves as a reference point for electrical potential. When a fault occurs, such as a short circuit between a live conductor and a metallic enclosure, the fault current flows through the grounding system back to the source. This causes the circuit breaker or fuse to trip, interrupting the flow of current and preventing a sustained electrical hazard. The effectiveness of the grounding system depends on several factors, including the impedance of the grounding conductors, the quality of the connections, and the resistance of the grounding electrode. Low impedance grounding conductors are essential for providing a quick and efficient path for fault currents to flow. Poor connections can increase the impedance of the grounding system and reduce its effectiveness. A low resistance grounding electrode ensures that the earth provides a stable and reliable reference point for electrical potential. Regular inspections and testing of the grounding system are essential to ensure that it is functioning properly. Grounding conductors should be checked for corrosion and damage, and connections should be tightened as needed. The resistance of the grounding electrode should be measured periodically to ensure that it is within acceptable limits. In addition to the grounding system, other safety measures are also important for preventing electric shock in electrical rooms. These include insulation, guarding, and lockout/tagout procedures. Insulation provides a barrier between live conductors and personnel, preventing accidental contact. Guarding involves the use of physical barriers to prevent access to energized equipment. Lockout/tagout procedures are used to de-energize equipment before maintenance or repair work is performed. By implementing these safety measures, it is possible to significantly reduce the risk of electric shock in electrical rooms. Now, let's elaborate on fire suppression systems, which are vital for mitigating the risks associated with electrical fires in electrical rooms. Electrical fires can be particularly dangerous because they often involve energized equipment, making it difficult to extinguish the flames safely. Traditional water-based fire suppression methods can be ineffective and even hazardous in such situations. Therefore, specialized fire suppression systems are required to protect electrical rooms. These systems typically use clean agents, such as FM-200 or carbon dioxide, to extinguish fires without damaging sensitive electronic equipment. Clean agents are non-conductive, non-corrosive, and leave no residue, making them ideal for use in electrical environments. The fire suppression system typically consists of a network of detectors, control panels, and extinguishing agents. The detectors are designed to sense smoke, heat, or flames, and they trigger the control panel when a fire is detected. The control panel activates the extinguishing agent, which is released into the room to suppress the fire. The design of the fire suppression system should take into account the size of the room, the type of equipment present, and the potential fire hazards. The system should also be regularly inspected and maintained to ensure that it is functioning properly. In addition to clean agent fire suppression systems, other fire safety measures are also important in electrical rooms. These include fire-resistant construction materials, fire-rated doors and walls, and smoke detectors. Fire-resistant construction materials can help to contain a fire and prevent it from spreading to other areas of the building. Fire-rated doors and walls can also help to contain a fire and provide a safe escape route for personnel. Smoke detectors can provide early warning of a fire, allowing personnel to evacuate the room before the fire spreads. Regular fire drills can also help to ensure that personnel are prepared to respond to a fire emergency. By implementing these fire safety measures, it is possible to significantly reduce the risk of fire damage and injury in electrical rooms. Lastly, let's consider personal protective equipment or PPE, which plays a crucial role in safeguarding individuals working in electrical rooms from potential hazards. Electrical rooms can present a variety of risks, including electric shock, arc flash, and exposure to hazardous materials. PPE is designed to provide a barrier between the worker and these hazards, reducing the likelihood of injury or illness. The type of PPE required will vary depending on the specific tasks being performed and the potential hazards present. However, some common types of PPE used in electrical rooms include firstly, insulated gloves, which protect against electric shock. Insulated gloves are made of rubber or other insulating materials and are rated for specific voltage levels. Secondly, safety glasses or face shields, which protect against arc flash and flying debris. Arc flash is a dangerous electrical explosion that can cause severe burns and eye injuries. Thirdly, hearing protection, which protects against loud noises. Electrical equipment can generate high levels of noise, which can damage hearing over time. Fourthly, fire-resistant clothing, which protects against burns. Fire-resistant clothing is made of materials that are designed to resist ignition and prevent the spread of flames. Fifthly, safety shoes, which protect against foot injuries. Safety shoes have reinforced toes and soles to protect against impacts and punctures. In addition to wearing the appropriate PPE, it is also important to ensure that the PPE is in good condition and is properly maintained. Insulated gloves should be inspected regularly for tears and punctures. Safety glasses and face shields should be cleaned regularly to ensure clear vision. Fire-resistant clothing should be laundered according to the manufacturer's instructions. Safety shoes should be replaced when the soles are worn or damaged. Proper training is also essential for ensuring that workers know how to use PPE effectively. Workers should be trained on the proper selection, use, and maintenance of PPE. They should also be trained on how to recognize potential hazards and how to respond to emergencies. By providing workers with the appropriate PPE and training, it is possible to significantly reduce the risk of injuries and illnesses in electrical rooms.